Okay, cool. Let's get started. I'm really happy to be here. It's the first Nginx conference. I want to talk about monitoring, and I'll explain a little bit why. So I think monitoring is something that everybody does and need, and I figured it'd be an interesting topic to discuss. I'm going to basically go through a presentation. If you have any questions, anything, you can, I guess, interrupt me. I don't necessarily, no need to wait until the end of the Q&A. So let's see. Here's how I'm thinking of structuring the presentation. First, presentation of who I am, the context that sort of brought me to present here. Then some observations about Nginx, and it'll become clear why I can make some of these observations. And then kind of walking you through monitoring, how you can monitor Nginx with logs, with metrics, like the different ways you can monitor Nginx, and then how finally you can monitor a ton of different Nginx instances. So let's get started. My name is Alexis. I'm at ALQ on Twitter, and I'm the CTO of Datadog. The dog on my shoulder is not a live dog. There's a lot of people asking me, but it's actually a fluffy animal. And what is Datadog? So what we do is monitoring. And that's really why I thought it'd be interesting for me to talk here, because so Datadog is monitoring the service. And one of the things we monitor is Nginx. I'd say, so we run as a service, which means that we get a bunch of customers that connect their infrastructure to us, and we receive performance metrics. And among these performance metrics that we receive Nginx metrics. Our stuff works really well for like large-scale environments. It's not really designed for 5, 10 servers. Is really designed for hundreds or thousands of servers. It works even better if it scales up and down, like typically cloud deployment, that kind of stuff. So what we do really is when you have a super wide infrastructure with a ton of a web-facing web tier that's sizable, data store tier that's also sizable, is we aggregate all that stuff, and then the idea is you can correlate things like Nginx performance with what's happening in the backend. I'll show you an example of that, but that's just to situate where I'm coming from, and also, to some extent, the kind of data I have access to. Does it make sense so far for everyone? Yes. Cool, great, thank you. I love feedback. So this is from our, from our website. So just to give you a sense of the things we connect to. So Nginx, of course, and then, Cassandra, I don't know, Docker, Node.js, and so on and so forth. So the idea is that you connect all these little things that are in your infrastructure, and it sends data to Datadog, and then you can do your monitoring. Now, what does monitoring mean? And this is just so for instance, for Nginx, you can kind of here I assembled like a little dashboard that has key metrics, and I'll go into the key metrics that we extract, and the idea is that you can really try to visually represent things that, or you can represent metrics in a way that you can consume and kind of act on. And here I have kind of Nginx tier at the top, and then database in the middle, and then kind of errors and deploys at the bottom, so to get a one snapshot view of everything. So that was just a short introduction of who I am, who I work for. Now, because we run Datadog as a service, I said we receive a lot of metrics coming from the field. I can make some quantitative observations. The sample population is in the tens of thousands, so it's not all the Nginx instances out there. Obviously, it's not all the servers, but it's sizable. It's not just, oh, I looked at 50 servers and I can make some observations. So across all the servers we receive, so in the tens of thousands, we found that Nginx is present in about 10% of the servers. So it's actually, it's both, it's not trivial. So it means that it's a very standardized, very common piece of infrastructure, and that's, I guess, why you guys are here. What was also interesting is that Apache, obviously the comparison was far behind, only 5% of the servers. So now, how you can attribute that? It's I would say mostly that there's some bias in the population we looked at. So obviously we're sort of a newer company, less than 5 years old. So if you set up an infrastructure over in the past 5 years, chances are you picked Nginx. I mean, if you didn't, then I'd be interested to see why. But still, there's still this. So Nginx has made obviously tremendous progress, and the other interesting point is that when people pick the kind of machine they run Nginx on, so if you look at how you can size machines, you have CPU, memory, network, and then I/O, and then what we can see, and I'll show you more details, is that actually CPU or CPU per dollar is the dominant resource. So the idea, this is a conjecture at this point because I didn't ask all the people who are running Nginx, but is that you size your machines based on the number of concurrent connections you want to run. Unless you run a cache of Nginx Plus, memory is a little bit less of an issue, as your instances will be pretty much stateless and just carry traffic through. CPU is also going to be useful if you want to do any kind of SSL termination, so that plays a role. So then I kind of went through our data set, like I want to get a breakdown of the percentage of instances, so it basically adds up to 100% per core count. And so the idea is that you have 10% of the machines we monitor that run Nginx run only one core. And then so I guess there are two modes, one at 2 cores and one at 8 cores. I was actually surprised to see at 32 cores, there's a non-negligible number of instances that run on pretty beefy boxes. There's no 6 because there's just a few machines running 6 cores. It's fairly rare, but that's what I got. Does that line up with how you guys size your machines?
Yes.
Okay, that's another good positive feedback, but yeah? Okay, so I then further reduced that and that's a slightly different decomposition, just to AWS. So I don't know who runs on AWS here? Okay, so maybe 30% of the 30%, 20%. So this is by machine class, and so for those, if you run AWS C3, C1, and so on, it'll mean something to you. If you don't, then C3 is sort of compute-intensive instances. So again, it sort of reinforces the idea that you pick you pick machines to run Nginx based on the amount of compute that you have available. So that's that for these observations. Now let's sort of dive into a little bit more into the topic. So there are a couple of ways you can monitor Nginx, and I basically isolated 3 because I think they give you the full coverage. The first one is you can use logs. The second one you can use status or metrics, if you will. And the third one you can use statsd, which is kind of a separate way, and I'll get into how it works. So monitoring with logs is sort of the canonical example of log processing. I mean, it's been around for forever. So the way it works is you centralize your logs somehow via a forwarder, which sends it to an indexer, and then there's a UI that basically accesses that index. These are some of the things you can use to do that: Logstash, Splunk, Logentry, Sumo Logic. There's a sort of a whole cottage industry of online sort of log management tools. So just quick survey, how many people use one of these tools, one of these that are listed? Pretty much everyone. Who uses sort of a grep over SSH?
Say again? Sure.
Who uses grep over SSH? Okay, all right. It works, to some extent it works. So I'm not going to get into the details of how you do it because there's like numerous tutorials on doing that. So rather, I kind of wanted to figure out, well, what is it good at and what is it bad at? So the name of the game is you get every single thing that Nginx processes and you index it. And so it's really good at finding lets you do forensics, i.e. look at what happened in the past, specifically looking for certain patterns, or it's to some extent good at looking for anomalies. So if you want to understand, again, you're looking for a particular attack, maybe in your logs. And of course, it's also good for, in general, content-driven analysis. So it could be because you want to know for marketing purposes what are the routes that are more often used, or it could be for kind of performance analysis, which are the heaviest pages and so on and so forth, the ones that are cached or not cached and so on. So I mean, you guys are all familiar with it. The things that it's not so good at is it's really low signal-to-noise ratio. So by that I mean you have to send a lot of data through this pipeline, and in the end you get, sort of, unless you're looking for something really, really specific, you're not getting a ton of data out. I mean, or you're getting data out, you're getting information out, such as how many requests have I processed in the past hours, how many had 200s and so on, how many had 500s. It's of course very valuable information, but you have to send a lot of data for it, And the long ways you send user agents and a lot of data that may not be super useful. So another way to look at it is that your costs to support this are, storage is cheap, but still, that's as you scale your infrastructure, that's going to grow. That's going to grow as fast, basically. And the other thing that it's not particularly good at is it's a black box. So by that I mean Nginx tells you this is what I did. It doesn't really tell you this is how how I am as a process. How many connections am I about to exhaust my connections, for instance. It doesn't really tell you that by just looking at the logs. It's just as long as things are happening, you'll see it in the logs. But inside Nginx is sort of completely opaque. So it still has its place. It's still super important, but it doesn't give you kind of a full picture. The other way you can look at it is using metrics. So typically the pipeline is a little bit different. So you have Nginx there, instead of sending data, its logs or whatever, syslog or things like that. It just aggregates statistics about its state and then waits for somebody to pick them up. So you typically have a collector, which then is that's going to hit the status page of one Nginx, and then all these statuses are going to flow back to one place where it can be consumed. So we have basically two modules to do that. If you actually a quick survey: who uses Plus versus who uses open source? Any Plus users? 1, 2, 3, okay, 3 or 4. So for the rest of us, you have the stub status module. It really gives you very, very bare bone metrics. Sort of a cheap, human readable representation. For the Plus people, there's a lot more, and I'll dive in both cases in what it means. But it's a lot more appealing, I guess. I mean, it's almost. It actually gives you enough insight into what's happening inside your Nginx. The one caveat, or the one unfortunate thing with Nginx, it works really well, at least the open source version. So the problem is, in a sense, you can get by with just the bare bone metrics, because it's just serving static content or passing stuff through, and it just works. When you have the more sophisticated functions around caching and so on, then you need a little bit more instrumentation. So we do, my company, we can collect, so obviously Nginx basic, open source and Plus metrics. There's also a bunch of other tools that do that. So, Nagios, Zabbix. The Plus, as far as I can see, we're the only ones, at least that I found, who can consume Nginx Plus metrics. So when you do this approach to monitoring, it's, again, strengths and weaknesses. The strength is really lightweight compared to shuffling, gigs and gigs of logs every minute or every second. It's just a simple, the JSON. Even if you in Plus, the JSON is going to be a couple of Ks, and you can get it every second if you want, but it's not going to be. It's orders of magnitude less data that you have to shuffle around. So it's a lot easier to turn into some real-time monitoring. Yes, you can do real-time monitoring with logs, but that breaks at some point when the volume of logs that you have to index goes beyond a certain boundary or a certain threshold. With this scheme, you don't have to, I mean, you can have like thousands and thousands of servers, and it's a minute fraction of the amount of data that you would have to collect through logs if you wanted to get the same information. The cool thing about it too is that it's what we call a white box monitoring. By white box, I mean you can look inside, especially in the case of Nginx Plus. You have I don't know, maybe I'd say 50 to 100 different metrics you can look at. So it lets you introspect in a much more granular way. Whereas if you just look at logs, you don't see that. You just see that requests are being processed. The unfortunate thing about this this method, of course, is sort of the flip side of it is that you don't really have insight into what content is being generated, what content could be problematic, and so on and so forth. So you have some basic things, but you don't really know. So it really sort of two sides of the same coin more than two opposite way of doing things. Good so far? Cool. All right. So before I dive into metrics, let me propose to you a simple taxonomy of metrics. And by that I mean we can devise, or at least I posit that we can devise simple classifications across metrics, regardless actually of what metrics we're talking about, as long as they're performance metrics, that are super useful to kind of make sense of if you have 100 different metrics, you're like, okay, well, what should I look at? There's a way out of that. And if you have 1,000 different metrics, which one should I look at? Again, there's a way out of that. It's not just sort of folklore or shared knowledge. I think there's a method to it. So when you think about monitoring, when you look at a metric used for monitoring, the first thing you want to think about is try to figure out what it measures. And there are essentially two things that a metric can measure. It's either measuring work, and work is really like a measure of how much value you're providing, essentially, or you're measuring a resource. So in a general computing term, resource is like how much CPU you're consuming. It's a resource. Like you can have a machine that's completely maxed out because it's doing a lot of useful work, or you can have a machine that's completely maxed out because there's a bug in the kernel and the machine's doing nothing. So it's not a good measure of how much value the component is providing, but it's useful nonetheless. Now, in general, what that means, so conversely, work is, for Nginx, a measure of work is how many requests it's serving. And I have an example of that later on, but if you look at, in Nginx, even the open source monitoring, you have connections versus requests. Well, connections is a resource, and requests or measure of request is measure of work. Because people use a browser not to connect to Nginx. People use a browser to request content from Nginx, and then the rest. So that's really one way you can approach metrics. Is this work? Is this resource? If you're interested, there's a really cool way to then further analyze resource called use, which stands for utilization, saturation, and errors, from a guy who used to work at Sun and now is at Netflix, I think, which is, again, how do you approach monitoring with a very systematic mind? I very quickly, and I'll go through that in the various metrics, but utilization is how much of something of a resource I'm consuming over time. Saturation is this something that's maxed out, so things are piling up. And errors is how many errors am I getting over time. The second thing, the second dimension, so first dimension is work or resource, to keep it short. Second dimension is just a type, and it's super confusing there. If you read about some things like gauges, counters, rates, the terminology is not very, unfortunately, not very intuitive. So in the case of Nginx, you only have really two things. You have samples, gauges, which are sample like this is how many active connections I have right now. So that's a gauge. You have another gauge could be like what's the temperature in this room, for instance. Counter is just it accumulates. You sample every so-and-so and accumulates how many requests I've served since reboot, how many bytes I've sent or received, and that kind of stuff. The key thing there is that counters need to be derived to be meaningful. If you don't derive it, you just have a big number that keeps increasing. And the problem with that is that the value of that number highly depends on when the stats were reset. So you can't really compare two servers, bytes sent, bytes received in absolute. You have to derive them to essentially get bytes per second sent or bytes received per second. Does that little thing make sense? The little way to cut different metrics. This is going to be super useful. And it obviously extends way beyond the scope of Nginx, but I think that's how I approach at least performance monitoring using metrics. So applying this little taxonomy to what you can get through by open source metrics, I mean the metrics that are available through the status module, I think stub status module. So you don't have a ton to work from. It's I don't know, 5 or 6 or something like that. So you have current connections, which is a gauge, i.e. how many connections do I have currently in open, if you will, or so reading, writing, or idle. It's a resource because it's really the only reason why you care about that is you don't want to run out of connections. And it helps you size your parameters, but how many connections you have, it's highly dependent on who connects to your server. So what are you going to do? It's not, you don't want to alert on current connections. You just want to alert if idle is like too low, or if you have a spike, you have a sudden change, for instance, but you don't want to alert on just some absolute number. Accepted connections is another. Accepted and handle actually highly correlated. So you really care about a handled versus accepted if handled is going to be what's been accepted minus potential if you hit some limit in Nginx in terms of how many how many workers, for instance, you can have at any given time. Then handle is going to be lower. But otherwise, accepted connections, I mean, you should accept all connections, right? You should handle all connections that you accept. But what that value is going to be is highly dependent on how much traffic you're throwing at it. The interesting thing there, the last metric is request, and that's the only work metric that's available to you. It's really the true purpose of the server is like how it's serving requests. So that's the one you want to you care about. Again, it's highly predicated on what kind of inbound traffic you get. But in general, if there's one metric you should care about, it is requests. Because the rest, if there's a problem with requests, you'll figure out, okay, well, maybe we ran out of connections or something like that. But you could have decent 0 current connection, or all the other indicators could look fine, but then you're realizing that you're doing just a fraction of the request, and essentially you're like, okay, that's why request is really the one that you want to care about. One thing to note is latency. Here is not, you can't get latency through this module, so open source. But by that, you have to use logs or statsd, and I'll talk about statsd later. But essentially, if you want to know, well, what's the distribution of my request response time, you can't get that through it. This is not available. So if we look at plus, it gets more interesting. It gets more interesting because you have more insight into what the behavior of the server is. So you can get, I've picked 5 different essentially what I would call key metrics. There are a lot more, but I think this is a good starting point. So the first one is a measure of errors, 5xx errors. And by the way, type is, remember, gauge versus counter. Counter you need to derive, otherwise it's meaningless. But this is just so that I don't forget mentioning again. But 5xx errors, so essentially what's great, it's a measure of work because a 5xx means the customer is not getting anything back, or the client is not getting anything back. It's going to get an error back. So it's really the value you're not providing, the server is not providing value. So that's why it's interesting. What's cool about this metric in Plus is that you can get that without log analysis. So it's a lot lighter weight. It doesn't give you a sense of which URL particularly is giving 5xx, but you can at least cut it by zone or upstream, so you have a little bit of granularity there. But it's super lightweight to get, oh man, I have like a spike in errors. You know, what's going on? We just push some bad code or something like that. Another good way to look at it is to size it is alternatively is to divide that by the number of total requests. And so that's useful because that's going to be independent of basically how much traffic. If you have very cyclical traffic, you want to have something that's sort of baseline against weekends, nights, not getting a lot of traffic. You still want your error rate to be commensurate with what you get during regular hours. Another one that's useful is sort of idle versus drop connections. So this really measures whether your Nginx server is saturated. So if you're starting drop connections, or if you're running out of idle, you may be into some issue. You may run into some issues. For upstream specifically, you can look at active versus total. So if you have a limit on total, obviously you don't want to get too active to be too close to total. Otherwise, you'll start refusing. Refusing to serve requests, which is not good. Last one, again, always true. Requests per second, in this case per second, it's a counter, so you want to derive it, you get a request per second. That's a true measure of how valuable your Nginx instance is. Same thing applies, latency of serving requests and so on is not available through these means. Last method that you can use is, and it's a little bit more exotic. Actually, who uses and who knows about and/or uses statsd? Okay, so about maybe a few percent or 10% of the audience. So statsd is a fairly clever way to measure to transport metrics. I'll explain. So, and you can replace here Nginx with anything. So the idea is that, you can measure, so in the case of Nginx, you can look at the logs and just kind of see what's happened. If you have a random application that you're writing code for a random application and you want to know how many things it's doing per second, how many, how many, I don't know, widgets it's producing or how many errors you get. There's this cool protocol that came out of originally out of Flickr and then Etsy, and called statsd. It's a UDP-based protocol that just lets you submit metrics. So if in your code you can measure things, then you can send them through statsd. And it's by now it's pretty much the de facto standard to transport metrics. The cool thing about UDP, about statsd, is it's UDP-based. The cool thing about UDP is that there's no connection. The cool thing about no connection is that there's basically zero. It doesn't introduce latency or coupling between your app and the things that collects metrics. So in this case, there's a module out of Zebrafish Labs called Nginx statsd that upon each request will emit a UDP packet, usually to localhost, to something that listens on localhost. Let's say, okay, this is how long it took for me to process this. This is whether it's successful or not, things like that. And I have an example. So the cool thing about that is, so it's lightweight. It's UDP. It's UDP on localhost, on loopback. So it's pretty damn cheap. It's lightweight enough that it can be real time, and it's very standardized. It's standardized to the point that there are like tons of libraries to do that. So what that means is you can have with this module, you can tell Nginx to speak the same monitoring protocol than the rest of your applications use. So if you don't know about statsd, I highly recommend checking it out. It's totally it has some limitations, but otherwise it's a very valid way to monitor applications, kind of regardless of the application. It's great for custom metrics. You can make it content aware. The problem is not comprehensive. So that module in particular, the Zebrafish thing, is not going to measure everything in Nginx. You could arguably make it kind of do that, but it's going to be a lot of work. So just an example of what it looks like. So in this case, this is straight out of the documentation for that module for location slash. Each time you hit that index page, increment. So and then it's usually every 10 to 15 seconds it'll flush. So it'll say, okay, well, I served. If you hit that page 100 times a second, it'll increment 100 times in a second, and then that'll tell you this is how many times that particular location's been hit. So you can make it sort of content aware there, where you can specific locations you can count differently. So statsd count, which is just, oh, I'm counting things. Your product.pages.index request is just the name of the metric you want to have. So you can replace your product by whatever, of course. You can do, of course, only if only if it's successful, and then you can time things. So this is where it's interesting, where you can measure latency. And so what that gives you is, in real time, gives you a distribution of your response time for that particular location. If you hit 1,000 times a second, it'll send a value 1,000 times in a given second, and then statsd will collect the little histograms. You'll see, oh, is this my average is this, and my 3 sigmas if it's normal is this and that, or it's super useful to gauge the performance of a particular location. Last thing you can do is at the bottom, you can be a little bit more sort of sophisticated and bring some custom header. I mean, that's the kind of stuff you can do. Anybody uses that module by any chance? Yeah, okay. Do you like it? Okay. Did I betray the intent of the, okay, cool. Did you write it?
Yeah.
Okay, well, there you go. Okay, so I want to recap that part of the presentation by saying essentially, so these are 3 methods. You use logs, you use sort of the status approach to Nginx, and you use statsd. They're great in combination, at least the first, especially the first 2, because they come out of the box and you don't need to. Statsd is useful because it's great if you want to measure very specific things, but overall, the takeaway there is there's no single method that gives you everything. So you kind of have to mix and match. It comes to no surprise to anyone, I think, because you all have you guys are all using log management tools to index your logs, and you also have some kind of monitoring in place. So, but I kind of wanted to go through why I think you still need a multi-pronged approach. Now. So what happens when you want to monitor a lot of Nginx? And here I want to kind of more establish what I think, whatever tool you choose, it has to have certain properties or qualities to make it manageable. The first thing it has, so let's say you have, I don't know, so who has more than 1,000 Nginx instances in production right now? Okay, more than 500. Okay, so more than 100? All right, more than 2? Okay, cool. No, so sort of joke aside, the idea when you have, obviously 1,000, 500, even 100 Nginx instances is, it's like, it doesn't really matter if you have 100 running or 95 or 98 or 106 or whatever. It doesn't really, the individual server doesn't matter. The individual instance doesn't matter, because ultimately what you use Nginx to deliver, to serve some content, or to take posts or serve gets. That's what matters. The rest, like how many servers it takes for you to run, I mean, who cares really? So what that means is that when you look at monitoring at a higher level, you kind of need to aggregate all that stuff. So if you look at number of connections or number of requests, for instance, per second, you want the aggregate across all the machines, because that's what you're going to track. If one machine gets out of commission, it crashes or it burns, as long as you can keep serving the same amount of requests, yes, you want to replace that machine, but it's not a matter of life and death. And I think the previous approach to monitoring when things were a lot more static, when you have just racks of servers, and once in a while, every 6 months, you'd add more servers, which is still, obviously a mode of operation, but we're seeing more and more very elastic stuff. When that was the case, monitoring was predicated about or around watching individual hosts, so individual Nginx 1, Nginx 2, Nginx 3, Nginx 25, and so on, to the point where machines had like individual names. Now, of course, it's completely untrue. If you're thinking about it, 1,000 Nginx machines, like, what are you going to do? You don't care if number 27 has issues or not. So you have to aggregate that stuff, and really, it's all about metadata. By that, I mean it's all about you want to think in your monitoring in terms of, I care about Nginx, I care about Nginx and aggregate, I care about how much requests I'm processing. I don't care about individual machines. So that's the pet to cattle. Instead of considering machines like pets where you name them individually, you consider them like cattle where it's a volume game. The last thing you want to do is do correlation. So I'll just illustrate those 3 points very quickly. So aggregation, your monitoring has to be able to do aggregation. It's by default for log-based monitoring. Because when you do log-based monitoring, what you do is you send all your logs into one place, and there you go. There you have aggregation. And then you can look at, oh, show me how many, the distribution of 500s per server, or the number of times somebody tried to run an exe on my Linux machine per rack, stuff like that. It's not on for metric-based monitoring, so you're going to need something to do it. Ideally, I think you would want to get something, so the kind of data you would want to consume is something like that, where you're able to look minute by minute, second by second, kind of there are, I don't know, maybe 100 machines reporting, number of connections per host. So it kind of tells me that they're all-ish between 0 and 40 with some spikes around 80. This is cool because if I see a value at 200, it means, wow, that's an outlier. What's going on there? But overall, I don't care which machine is reporting this point and which machine is reporting that point. I just want to have some bounds of they should have no more than 100, let's say. And if it falls into that 0 to 100, I'm happy. The metadata you want to, so if you're able to monitor using metadata, you can do some really cool thing. And that's really where you stop worrying about hosts. You just start worrying about some properties that hosts have. So for instance, here I represented, this is real data, connections per data center. And so now the context of that is that there should be load balance across all data center. But there's a time clearly between whatever and whatever where one of the data center gets more connections. So it could be because the load balancing is wrong, it's just sending more requests. It could be because the machines there are slower, so they take longer to process connections, so the connections stack up a little bit more. Either way, I don't care about which machines are in each data center. I do care that I have this sort of anomalous behavior, and that's a cue for me to start investigating. Or maybe I'm like, yeah, I don't care, it's fine. But at least you have to be able to do that. So whatever monitoring tool you choose, make sure you can do that if you start to scale your infrastructure. Last thing you want to be able to do, of course, is just a simple realization that Nginx is not the only piece of the infrastructure. So this is an example that I pulled from our data. Is there was sort of a spike in kind of load. So one machine, and it's more like correlation. Maybe there's more requests and it induces more load, or maybe there is, actually, no, it's got to be causation in this case. So there's more requests and it induces more load. If there were more load, you'd see fewer requests for that thing. So overall, the idea is that you can, monitoring Nginx, you have different ways to do it, but you should also feed that into the rest of your monitoring. I have a little plug slide, so Datadog, that's what we do for a living, this kind of stuff. And I thank you. Any questions? questions?
So
Yeah.
earlier you said that you take anomalies. So what kind of anomalies do you?
Well, so yeah. So the question is, I mentioned anomalies monitoring to detect anomalies. It really depends. I mean, we're not in the context of this presentation. I'm not saying that you can. I mean, there's a way to detect anomalies. You use logs to detect anomalies, or you could use metrics to detect anomalies. But what is an anomaly is highly dependent on your use case. So you could find standardized ways to do it, but in essence, these are just tools that let you think about how do I worry about anomalies. Yeah.
One of the first slides you had, I think one of the metrics that you're monitoring is CPU, and then you had /$.
Oh, yeah.
I was curious what that meant.
Oh, so yeah. So this is mostly CPU $2. So this is really for this slide. I say that because I mean you can say the core count is going to be related to the amount of money you're going to spend for a server, whether in AWS or not. So it's interesting. So and there's a tension there. You can have machines with lots of cores probably tend to be cheaper per core within some reason. Their operational costs are going to be probably lower because your human costs of running an infrastructure are going to basically increase not with the number of cores, but number of chassis, as it were. So there are people. So the C3L is in this case is a sort of run-of-the-mill kind of instance, and then there's the other way you can do it is to run on really beefy instances. So beefy instances meaning probably cheaper operationally speaking, maybe a little bit cheaper if you want to buy them. But there's just the concept that CPU is one thing, but you don't want to run Nginx on a 1,000 core if that existed machine, just too expensive. So it's like just the fact that these CPU and essentially dollars per whatever hour is come into account. Yep.
I haven't used that D before. I understand you can send all those metrics on over to it. Then how do you retrieve and do?
So there's a couple of tools. I mean, we consume that. There's a tool called Graphite, open source, that does that. So if you look for statsd graphs, probably you'll find there's a zillions of different ways to consume that. The idea statsd is really about transport and protocol. It gets into statsd and then it goes somewhere else where it can be visualized and so on. But I highly recommend checking it out. Cool. Any additional questions? All right. Well, yes.
Is there a way to monitor to sample the request time through the Nginx?
Just the basic Nginx? Well,
Either like the headers and body.
yeah.
Kind of have a sample, not every single.
Just sample. So can you sample? I mean, you.
Get an idea what kind of traffic is flowing.
Yeah. If you look at your logs, sorry. Can you? I can think of different ways to do that. I mean, you could use a log-based approach. This person's gonna stop bothering me. It could be. So the other way you could. That's a good question, actually. I'm thinking, it's just dumping traffic once in a while. That could be one way to do it. It's just not. It's not very. Yeah, you could do it. Like you could. I'm trying to think. That's a good question, actually. The problem with sampling is that you're going to have, you have to sample enough that you get kind of a. My typical approach would probably be to do it at the log level, so to have a process that just tails the log and just accumulates, it could be like awk or something like that. It just kind of looks at the last 100 lines once a second. If you have a lot of traffic, the last 10 lines, and just performs, like extracts the URL. That's probably how I would do it, just as a simple way without doing like, socket level tracing and stuff like that.
Maybe someone already wrote the plugin or something.
I don't know. Yes, maybe that's the short answer. Cool. All right. Thanks.